Start it. Distributed care is providing healthcare services where the person is in need. It's delivering care wherever you are. Distributed care solutions include things like telehealth, remote patient monitoring. I'm sure those are the things you're thinking of, but it's also about connecting up the Internet of medical things and processing data at the edge, so that that would include things like medical imaging. And I'm going to be focusing on medical imaging, but it's broadly applicable. Mark that on your sheet. All right, healthcare professionals are facing explosion of data growth, and a lot of that can be attributed to medical imaging. They're also facing shortages of clinicians that can process all that data, and healthcare costs are rising. These two emerging technologies that I'm going to focus on, computer vision and deep learning or artificial intelligence, can help address these problems and challenges. Intel has recently, just this year, delivered a tool that
Hey-o. You getting levels over there?
And computer vision and deep learning development.
Yeah.
The toolkit is called Open.
Did you see that?
And it
Did you see that?
Intel hardware and software platforms speeds the development
One
of time
tool.
to deliver
One
deep
tool.
learning insights for, on top of that vast amount of medical imaging data that's being generated today. It also enables more efficient use of, scarce resources. The clinicians are scarce. And delivering these solutions on the medical imaging infrastructure that is existing today. So that's the key cost savings. OpenVino is an open source toolkit for accelerating deep learning and transforming vision data into healthcare insight. It drives deep learning at the edge and to enable distributed care solutions. Developers write once to run on any Intel platform. So it would include CPU, GPU, vision processing units, and FPGA. It includes a model optimizer, so you take a model that may have been trained anywhere, run it through the optimizer, you're now optimized to run on the platform. It includes libraries and is compatible with many open source AI frameworks that you would be using, so this makes it easy to deploy. The benefit for medical imaging solution healthcare providers would be that these computer vision and deep learning are being used to identify tumors, detect pneumothorax using lung segmentation, predict bone age, screen for diabetic retinopathy, and with our latest Intel Skylake Cascade Lake platform with Deep Learning Boost, you're going to be able to do segmentation of cardiac chambers, which is difficult to do. You have to keep up with the beating. So the underlying benefit of all of this is that it's running on an Intel architecture, and that means that the deployment costs are lower and that you have less complexity with the solution. There's examples here with GE Healthcare in reducing the workflow that needs to be, that the radiologist has to go through. They're running faster, it's on Intel architecture. In China, they're using it to train images faster and allowing these radiologists to focus on the more difficult use cases, so they have freeing up their resources. And here with Siemens, we're doing real-time. This is using the Xeon processors and OpenVino to optimize and run on existing architecture, eliminating the need for expensive accelerators.
All right, thank you, Wendy. Everyone join me in giving Wendy a hand. And Sharks, you're up. No, Wendy, go ahead and stay for your shark experience.
So I'm not in healthcare. Can you describe to me what this product is in like one or two sentences? And like what problem is it
It's
solving?
an
What is it?
artificial
Yeah.
intelligence model optimizer, and artificial intelligence.
Okay, let's say I'm not in technology.
Right, so
What is?
artificial intelligence can look through your data, your visual data, and see the things that would take you a long time to go through because there's so much data to look at. So some of it can point you to this one is something that is important to look at because we see in it that it has the lung segmentation shows that there's a probability that there's pneumothorax, or we can see that there might be a thyroid tumor here, and so you have to spend less time.
How does this differentiate it from other models or other machine learning algorithms that exist now, or platforms?
The differentiation, other AI developers and chip makers do have solutions that do similar things, but Intel has an end-to-end, and no one has the breadth that Intel has, and we need to be supporting this at every level, and we're in there, and we're helping our healthcare customers to be able to optimize on their standard architecture that's cost-effective and, easy to maintain and fits into.
So Wendy, you had great slides, but like my fellow shark here, Adam, I just felt like you never really got to the point here on what makes this unique, and I didn't understand what the problem was, nor did I understand what the solution is. It also sounds to me like this is some of the same stuff that I've heard in many other forums. It's just a repackaging of it. Can you address any of that?
But you didn't understand that the problem is that there's an explosion of data, there's scarce clinical resources to be able to process all that data, and you want to be able to do it in a cost-effective manner. So this solution helps you read that information.
Loving you forever.
Re-architect your whole infrastructure.
What I
And it's gonna
Can it run on any server?
optimizing for all of Intel platforms.
Okay.
Yeah, it runs on CPUs, Intel's graphics processing units, Intel's vision processing units like NVIDIA's, and also FPGA. So now you can write it once, and it runs on any platform that Intel is providing.
So help me out with a real-world example. So if somebody comes in for an MRI of the brain, there's a radiologist that's looking at that. When does this enter the process, and how does it help?
It's at the edge, right there. So as the images are being collected, the imaging providers like GE, Siemens, Philips, they're all using artificial intelligence to look at what these images look like to detect certain things that they're looking for in the MRI.
So it's a resource or a check in case the radiologist misses something, or?
No, so Siemens would create a model that would find this problem, right? They're the experts, right? And then that model is optimized to run on the architecture that's already inside that scanner. And so that way they don't have to go out and re-architect the system, get it passed through FDA again. It's going to be running in the infrastructure that they have today. And it's going to be cost effective because with accelerators for artificial intelligence, it's not cost effective.
We have time for a quick question, quick answer.
Do you know what your first use case is? Where's your first big win for this?
The first one was that GE one. They challenged us to make it cost effective and to meet a certain level. And we took OpenVINO and ran their models, and we beat it by 5.5 or 5.9 times what they expected. And so this enables them to go out and continue to use Intel processors, and it saves them money, it saves the customer money.
All right, thank you, Wendy.